Huh, that's a new one. Either way, into the bucket. Welcome back to the basement. As you can see by my attire, it's a little bit more nippy. We just had a glimpse of summer and now the weather has dropped out on us. So I'm kind of cold. Not really. It's about 63 degrees down here on average. But I got some new high-speed Chinesium that I just ordered off Amazon. This is a reproduction, and right there, made in China. This is a reproduction Trangia stove with a pot stand, and it comes in a pouch, all for $14. The Espit Trangia style stove that I ordered years ago was $17 at the time. So for a few dollars more, you get HO in Deutschland, for those of you who sprechen Sie Espanol. Anyway, this one, a little sharp on the edges, but this one mirrors the fit and function. I don't know about the function yet, but it mirrors the fit, if not the finish, of the Espit style Trangia. But again, you can tell this one's well worn and seen some actual misuse. But I definitely don't remember it being as sharp on the edges. A little bit more refinement on the German version. Plus they have their, and it's probably, I don't know, maybe even made in China at the time, but a little bit different quality standards. Could tell almost by the heft. Get the scale out. 63 and then went to 62 when it balanced out. Let's check the one that's made in China. Fabergé in China. 54. 55. Difference in a gram is negligible with this scale. 55 grams. All right. So a little less material, as the dimensions, when one looks, the Espit is slightly taller on the reservoir. The same size. Let's see if the threading is the same. Yep, threading is the same. I might actually use this O-ring to bring this one. Well, maybe not. That's close enough. The stamp outs, 1, 2, 3, 4, 5, 6, 1, 2, 3, 5, 6. Yeah, but the stamp outs on the inside are the same, as you can also see at the bottom. Like I said, just the reservoir being a little bit taller. It looks like the holes, big hole, little hole, big hole, little hole. It looks like there's roughly the same number. I'm not going to count every single last one. Anyway, I bought this to have a brass burner with a pot stand, kind of as an auxiliary. I think you can bend these in. This is aluminum, so you can't bend it. It will still, steel is flexible, but if you bend it too much, it tends to break. Same thing with aluminum. All right, so now that is bent just enough to keep the bottom of the pot from being in contact with the ground and the aluminum that would act as a heat sink and draw the heat into the ground away from the pot. That would make it a little bit more difficult to gasify your alcohol fuel, although it would have to be quite the cold surroundings for that. Now what I noticed that this doesn't really do is it doesn't serve as the most efficient windbreak. So what a lot of people do is they'll either buy a windscreen or take their heavy duty aluminum foil, unfold it and then shape it around to create a windbreak. You can fold it down even more so that when your pot is on the stand, the windbreak doesn't interfere with it as much. No need for an exact demonstration, considering that you can use your imagination to extrapolate how that would go. Anyway, I wanted to test burn this one. While I'm doing that, I'll do another unboxing of another high-speed piece of Chinesium, which is the more specific purpose that I bought this for. As a camp heater. Let's dim the lights and see how this blooms. It's the longest I've had my knuckle hair anyways. I'm trying to lose it. That was pretty quick. I would say that thing is burning at peak efficiency. Thanks to, again, that idiot melting the rubber on the trangia and the residue that's accumulated over the years. That one actually burns less efficient than this. I do like the way this one is going. That is worth the price of admission already. While I'm at it, and I'll unbox this. This is a small camp heater designed more for a tent than anything else. Maybe a little small cabin, but something with adequate ventilation. And it's also technically designed for a like a gas stove, as in propane, liquid propane gas, or LPG as it's known acronym-wise. And then also butane burners. But yeah, this one also made in China. Very large in profile. Heavier than I thought it'd be, but it is made out of supposedly stainless steel. And you're going to need that for retaining and radiating heat. Nothing really to it. Looks like 4 Phillips head screwdrivers for the top, which is, it says hot on it, which is a kind of like stating the obvious. But having a hot surface on top that lays flat, if it does what I think it'll do, that is a good thing, because you can maybe boil up some water. We're going to snuff this out. Conserve a little fuel. And then we'll see how this best positions. Alright, let's fire this up and then see where it goes from there. Do a little time check here. Now what I could already see is fumes coming off of this. That's never good when you buy something from China. Maybe I should have done the burn-in outside. Those are definitely some kind of factory fume. That is not some afterburn of alcohol. It actually seems to be dissipating during this burn-in. So again, this is designed to take some high BTUs. I don't like that, really. That is weird how that is throwing all those fumes. But this is supposed to take some high BTUs from a burner, from a liquid propane gas burner. So for it to be throwing all those fumes from the alcohol, that's kind of disheartening. So you can tell that it's not the fumes from any alcohol being unburnt, because when I put it back on, it ceased throwing that vapor. If it was from the unburned alcohol, it would continue to throw that vapor. And it seems now that it's burning in, we got a pretty decent glow on the metal. And as the heat transitions down the metal a little bit more, what it's looking like is it is further burning that gas. Just like that Evernew works when you put the power burner on it. So the issue I would have with that is if it continues to heat up and the flame continues to burn the gas as it goes down, there is the potential that the alcohol could actually pop or overboil and vaporize and spill, causing a small uncontrolled fire. And while that is a concern of mine, I'm just going to let it burn. There's a reason. Because I want to know how this works if I end up taking it out into the field. And I'm not totally stupid. Got a little fire extinguisher here. So yes, this is radiating a significant amount of heat. Although with all that off-gassing, I'll have to see if that continues after the burning process. But with all that off-gassing, that could get pretty toxic if not properly ventilated. Let's just take a look at what the temperature is around here. No way. That just read 73.5 degrees. 66, 67, 63 on the wall. The temperature all the way up there, 82.5. And that's coming off of something radiating well in excess of 420 degrees, which is the maximum of this. At the coolest point, at the bottom, we are looking at 95 degrees, and when I touch it, I can confirm 95 degrees. About halfway up, 200, 300, 400 on the metal. On the outside, we're looking at 140 right here. Can confirm 140-ish. And then once you're up here, 429.5. So yeah, it is definitely throwing some heat, as if you couldn't tell by the fire. Well, at the back of the hands being the most sensitive, I can feel the heat radiating out to about 4.5 feet. Once you get within about 2 feet, it's very noticeable on the skin. Even the palms of the hands have a good proprioception on that. If you get too close right here, it's bearable, half a foot standoff, but it starts to become unbearable after, I would say, I could probably keep my hands here the whole time, but I can foresee it being uncomfortable after about a minute. It's starting to get uncomfortable. Which means that the air temperature is likely in excess of 130 degrees. Surface of my hand, and that's of course with body fluid, blood circulating through, and the sweat or proctal glands. I can definitely feel them activating to mitigate that heat. Looking at a surface temperature of about 123 and a half, 124 degrees, 107 back there. Yeah, this thing definitely throws some heat. That's what it's designed to do. Would I use it inside of a tent? If I didn't want to wake up again, maybe. But that's usually not the goal of camping and staying warm. Would I use it in a small vintage shelter, maybe like a stone hut or something, or a mud hut? Maybe. But I'd probably rely on some kind of wood burning apparatus. So again, the reason I would rely on wood is because it's more plentiful to burn for heat, whereas this is more of a novelty. Because any real camper will tell you that the value of your cooking fuel is a lot more for providing you, some sustenance than it is to provide you actual heat. So for this jug here, this denatured alcohol, well, it's not fit for ingesting. You can actually use it to treat cuts or wounds, because it is, in essence, 200 proof alcohol, ethanol with a little bit of methanol added to make it unpalatable. So that little burn, and I didn't measure out how much liquid was going in it, burned for about 8.5 minutes. There's a noticeable smell that you usually get when you're first burning in some kind of metal product, like either a stove or a seasoned pan. Let's see the temperature on this. Surface temperature up here is well in excess of 430, 425, 400. It's cooling down pretty rapidly, 393, 391, 389. So it's cooling down about 2 degrees a second, and that's going to be more than likely logarithmic rather than linear. Actually, it's pretty linear. 360, 358, 356, 354, 352, 350. So almost 2 degrees every second. Down here, cool enough to the touch. I can pick it up. Starts to get hot up top there. About halfway up, I can grab it. So it definitely radiates heat pretty well. The inside mesh, pretty tolerable. But again, you can see there's a little bit of a soot buildup on the inside. I don't know if you can see that unless I brighten the lights. Yeah, a little bit of a soot buildup. Anyways, when you're burning that off, the hydrogen strips off, combines with the oxygen in the air, because that's the main thing that's burning, is the hydrogen. Combines with the oxygen. You have basically H2O, water, and carbon monoxide, carbon dioxide. These are the off gases from the combustion. Anyways, that water then recombines with any unburnt alcohol, forms a vapor and any unburnt carbon, and it creates that heat soot. Give it a little touch. You can see right there on the tip of my finger the soot. That is significantly cooled down. 124 degrees, metal being a wonderful conductor of heat, 196 at the highest point. So, this gets hot enough to where you can definitely boil water and cook on top of, simultaneously heating, and it provides somewhat of windscreen. However, it is heavy. So, my go-to from back in the day, other than foil and a pot stand, was this little guy. More on that in the next video. GoPro, stop recording.